Right now, you believe you are awake. You are reading this. You are aware of the room around you. You can feel the weight of your body, the temperature of the air, the quiet hum of whatever is nearby. You are conscious. You are present. You are certain of it. And you are wrong. Not partially wrong. Not wrong in some philosophical, abstract, late-night conversation kind of way. Wrong in a way that neuroscientists have been quietly proving in laboratories for decades, using brain scans and reaction tests and sleep studies that keep producing the same uncomfortable result. The state you call being awake is not a single, stable, fully on condition. It is a spectrum, a sliding scale. And at any given moment, including right now, you are somewhere in the middle of it. Never at the top, never fully switched on, drifting constantly between degrees of awareness you cannot feel and cannot measure from the inside. Your brain is never entirely awake. In the 1990s, a sleep researcher named Claudio Stampi began studying what he called microsleep, tiny episodes of sleep that last between 1 and 30 seconds, occurring without warning, without the person's knowledge, and often without any outward sign at all. The eyes may stay open, the body may stay upright, the person may even continue what they were doing, nodding along in a meeting, watching a screen, holding a conversation. And then, a second later, they are back. No memory of the gap, no awareness that anything happened, just a clean, invisible cut in consciousness that nobody noticed, least of all them. You have almost certainly experienced this today, but microsleep is only the most visible edge of the problem. The deeper issue is something researchers call local sleep, a phenomenon discovered in 2011 by a team at the University of Wisconsin-Madison led by neuroscientist Giulio Tononi. What Tononi and his colleagues found was extraordinary. Using electroencephalography to monitor brain activity in subjects who were awake, alert, and performing tasks, they detected small clusters of neurons, individual regions of the brain that were falling asleep while the rest of the brain remained active. Not the whole brain going offline. Pieces of it, quietly, without announcement. The neurons would enter a state identical to sleep. Slow, synchronized waves replacing the fast, irregular activity of wakefulness, and then return to normal, all within fractions of a second, all while the person remained convinced they were fully conscious and performing normally. In some cases, they were. In other cases, their performance on the task degraded measurably without them realizing it. They made errors. They missed details. They slowed down. And when asked afterward, they reported feeling fine. Awake, alert, present. This is the part that should make you pause. Your brain is not a light switch. It does not go from off to on when you open your eyes in the morning. It is more like a city at night. Most of the lights are on, most of the time. But in any given moment, some blocks are dark, some streets are quiet, some districts have gone to sleep while the rest of the city keeps moving. You experience the lit parts. You have no access to the dark ones. And you assume, because you cannot see the darkness, that it isn't there. Think about the last time you drove a familiar route and arrived at your destination with no memory of most of the journey. Or read a page of a book and realized at the bottom that you had absorbed nothing, that your eyes had moved across every word and your brain had processed none of them. Or sat in a conversation and suddenly realized you had missed the last 30 seconds entirely, that someone had said something and you had nodded and now you had no idea what it was. That was not distraction. That was not laziness. That was your brain going locally, partially, temporarily offline, and then coming back online and filling in the gaps so seamlessly that you barely noticed the seam. Researchers call this phenomenon inattentional blindness when it applies to things you fail to see, and change blindness when it applies to changes you fail to detect. In a famous experiment by psychologist Daniel Simons at the University of Illinois, subjects were asked to watch a video and count how many times a group of people passed a basketball. In the middle of the video, a person in a gorilla suit walked through the scene, stopped, beat their chest, and walked away. Nearly half of all subjects never saw the gorilla. They were looking directly at it. Their eyes were open. They were awake, and they saw nothing. Because attention is not the same as awareness, and awareness is not the same as being awake. There is a third layer to this. Beyond microsleep and local sleep lies something called the hypnagogic state, the threshold zone between wakefulness and sleep that your brain passes through twice every day, once as you fall asleep and once as you wake up. In this state, which can last anywhere from seconds to several minutes, your brain is running two operating systems simultaneously. The logical, language-based, sequential thinking of wakefulness and the associative, image-based, rule-free thinking of sleep are both active at the same time. You may experience vivid flashes of imagery, hear sounds that aren't there, feel sensations in your body that have no physical cause, or have thoughts that feel profound and fully formed, but dissolve the moment you try to hold on to them. Thomas Edison knew about this state. He used to exploit it deliberately. He would sit in a chair holding a steel ball in each hand, with metal plates on the floor beneath him. As he drifted towards sleep, his hands would relax, the balls would drop, the clatter would wake him up, and he would immediately write down whatever had been in his mind at the threshold moment. He believed, and many researchers now agree, that the hypnagogic state produces a kind of thinking that full wakefulness cannot access. Connections between unrelated ideas, solutions to problems that conscious logic had been unable to crack. A form of intelligence that only emerges when the rigid structure of full wakefulness partially dissolves. Salvador Dali used the same technique with a spoon. What this suggests is not just that you are never fully awake. It suggests that full wakefulness, if it were even possible, might not be the optimal state for a human brain to be in. The most creative thinking, the deepest pattern recognition, the most unexpected connections, these emerge not from the bright center of consciousness, but from its edges, from the moments when the system is partially offline, from the gaps. Your ancestors did not have a word for this, but they knew the edges. Ancient cultures around the world, from the Greeks with their concept of the hypnos, to indigenous dreaming traditions, to medieval European practices of deliberately waking in the middle of the night to think and pray in the quiet hours, treated the boundary between sleep and waking as a sacred space. Not dead time, not failure to be awake, a different kind of intelligence, a different kind of access. Modern neuroscience is starting to agree with them. A 2019 study from researchers at Harvard Medical School found that people who were interrupted during the early stages of sleep, just at the point of drifting off, and asked to report their thoughts produced significantly more creative solutions to problems than people who were either fully awake or fully asleep. The threshold, the half-on half-off state, was where the best thinking happened. You have been chasing full wakefulness your entire life. More coffee, earlier alarms, blue light blocking glasses and productivity systems, and morning routines designed to get you to 100% as fast as possible and keep you there as long as possible. And underneath all of that effort, your brain has been quietly doing what it always does: cycling, drifting, going locally dark, coming back online, crossing thresholds you didn't know existed, thinking thoughts in the gaps that you will never remember and cannot access from the fully lit center of your conscious mind. You are not a light switch. You are a city. And the most interesting things have always happened in the parts of the city that never fully wake up. Right now, you believe you are awake. And somewhere in the architecture of your brain, in some cluster of neurons that just went locally dark and came back online without telling you, something just happened that you will never know about. You were never fully awake, not once, not ever, and neither was anyone else. Subscribe. Ja.